Well, pre-calculus classes, as always, good morning, good afternoon, or good evening. I know I'd mentioned as we had started into section 4.3 that we cover some of it before we come back and cover 4.2, and then we will end up, after a couple of lessons on 4.2, finishing up 4.3. So, one of the things that we are going to be coming back to some are the special right triangles. And so, whether or not you have those notes handy, I will go ahead and certainly fill in these values because that is something that is going to certainly come back up, like I said, today. Now, talking about the unit circle, we're going to show you how these two triangles even fit within the unit circle. Let point P with coordinates x, y be a point on the unit circle. Well, I'm just going to pick a fairly random spot here. Point P has coordinates x and y. And what I am going to do is sketch in a triangle. We have our angle theta right here. Now, to get to point P, I have to go over x and up y. Now, the unit circle has a radius of 1. Well, from here, if we were to use SOHCAHTOA, well, the cosine of theta here would be adjacent over hypotenuse. The sine of theta would be the opposite over the hypotenuse. So, well, cosine of theta is x over 1, or x. Sine of theta is y over 1, or just y. So any point going around the unit circle has coordinates of cosine theta sine theta. So that's, the special right triangles, SOHCAHTOA. I mean, those really aren't based off of triangles. They're truly based off of the unit circle, and you can construct those triangles within the unit circle. So if we now go in and, fill in the coordinates, and what I'm even going to do is go back and find the page in the notes that actually has all of these. But at 0 degrees, and so I'm just going to go around and quickly fill in all of the degrees. And then we're going to talk a little bit about all of the coordinates for these points. And all right, so again, as you go around the unit circle, every coordinate is cosine and sine of that angle. Well, at 0 degrees, of course, this is one of the easy coordinates. You just go over 1 unit because our radius is 1 on the unit circle. Well, at 30 degrees, cosine 30 is radical 3 over 2. The sine of 30 is a half. So again, those exact values now will fill in on the circle. 45 is one of the easy ones because cosine and sine are the same. They're both radical 2 over 2. And really, as long as you know these first two coordinates, you'll be able to fill in everything else. Well, I mean, as long as you also know the 1, 0, up here it's 0, 1, over here it's -1, 0, and down here it's 0, -1. But as long as you know these two coordinates, you can fill in everything else. At 60 degrees, again, because of the co-identities or complements, sine of 30, cosine of 60 match. Cosine of 30, sine of 60 also match. So basically these two coordinates are just going to be flipped. 1/2 radical 3/2. Now, here's where it gets even easier. To go all the way around the rest of the circle and fill in the remaining coordinates, all you have to do is reflect. Well, 120 is a reflection of 60 degrees. You just reflect the x-coordinate over, and it becomes negative. Everything in quadrant 1, positive, positive. In quadrant 2, coordinates are negative, positive. So negative radical 2/2, positive. And then negative radical 3/2 and 1/2. Now, from here, in quadrant 3, again, you can reflect all of these coordinates down. In quadrant 3, everything is negative. So here, the x-coordinate remains, the y-coordinate becomes negative. Now, just be careful as you do go around. Make sure you do reflect coordinates down correctly. Of course, again, at 225, again, it's one of the easy ones where they're both the negative radical 2/2. And then 120, the negative 1/2 remains, the negative radical 3/2 becomes negative. And then in quadrant 4, you could look at it one of two ways. You could either reflect quadrant 3 over, or I actually almost like saying we're just going to reflect quadrant 1 down. So, again, x-coordinates remain positive, y-coordinates become negative. So, in terms of filling in the unit circle, as I've said, I mean, really knowing these first two is key. Think about even the radians. Every 30 degrees is pi/6. Every 45 degrees is pi/4. And then as long as you know these first two coordinates, again, everything is just kind of like putting together the pieces of a big puzzle. So that is the unit circle. Now, let's say they asked you to, something like right here, find the point xy on the unit circle that corresponds to t. Well, t is 3 pi/4. Again, 1/4, 2/4, 3/4. So that's at 135 degrees. The ordered pair is negative radical 2/2, positive radical 2/2. 4 pi/3. Well, I don't have all of my radians labeled here, which, again, not a big deal. But, again, every 30 degrees is pi/6. 1/6, 2/6, 3/6, 4/6, 5/6, 6/6, 7/6, 8/6, which is 4 pi/3. So at 240, our ordered pair is negative 1/2, negative radical 3/2. So, again, just maybe a little different way, certainly, of, seeing a problem written with these. All right, other things. Find the exact values of the 6 trig functions at theta equals pi/6. Well, again, I know I just mentioned that every 30 degrees is pi/6. So, here is pi/6. Well, we have 2 of them. Cosine is radical 3/2. The sine, and you know what, let me actually use the actual angle measure for the rest of these, is 1/2. Now, I know we used some of these with an actual triangle before. Now, all you can do is just use those two exact values, get everything else from there. So cosine, the reciprocal identity for cosine is secant. So the secant of pi over 6 is 2 over radical 3, which again, 2 radical 3 over 3 after you rationalize. The reciprocal for sine is cosecant. Well, the reciprocal of a half is 2. Now, something that we have not necessarily talked about yet, but I'm even going to go to the last page if you have printed things off and talk about quotient identities. Well, quotient identities, if you think about SOHCAHTOA, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. So if I take sine divided by cosine, I get opposite over adjacent. So tangent is sine over cosine. Cotangent is the reciprocal of tangent. It's cosine over sine. Before I actually finish up example 2 and come back to example 3, just some reminders about your reciprocals. Sine is the reciprocal of cosecant. Cosecant is the reciprocal of sine. Cosine is the reciprocal of secant. Secant is the reciprocal of cosine. Tangent is the reciprocal of cotangent. Cotangent is the reciprocal of tangent. So now coming back to fill in these last two. So tangent, pi over 6. You take sine over cosine. Well, that is 1/2 over radical 3 over 2. Sine over cosine, which then 1/2 times 2 over radical 3 is 1 over radical 3. And then when you rationalize, it is radical 3 over 3. And then the last one, cotangent. Now, again, here is where I like writing all of my steps all the way through, and the reason is I don't want to, even if you realize, yeah, that's going to automatically be radical 3 over 3, flip the 1 over radical 3 for your reciprocal. And again, I guess I could make that pi over 6. So there are your 6 exact values at pi over 6. Find the exact values at negative pi over 4. Well, something that we've talked a little bit about, going counterclockwise, are positive. Going clockwise are the negatives. Well, every 45 degrees is pi over 4. Negative pi over 4 would just put you down here at essentially 7 pi over 4. So again, cosine and sine. So cosine negative pi over 4 is radical 2 over 2. Sine negative pi over 4 is negative radical 2 over 2. And again, from here, now we can just use all of our reciprocals. Again, starting with secant, it's 2 over radical 2, which when we rationalize is 2 radical 2 over 2, or radical 2. Now, the nice thing about cosecant here is, it's just going to be negative. You know, they're the same value. One's positive, one's negative. So negative radical 2 is our cosecant. Tangent, negative pi over 4. Well, again, sine over cosine. Negative radical 2 over 2 over positive radical 2 over 2. This one I'm not going to go through a lot of, flipping and multiplying. If I take a negative value divided by its positive value, it's simply negative 1. If we flip that for cotangent, it's also negative 1. So there is something that, these are fairly common things that we are going to ask you for exact values from unit circle angles. And then the only other thing that we will include here in this last set of notes, domain and range for sine and cosine. Well, again, because you can go around the circle forever, either positively or negatively. The domain for both sine and cosine are negative to positive infinity. Now your range on the unit circle, the maximum, minimum, or maximum and minimum values, again, because remember, x is cosine, y is sine. Well, you never have a value larger than 1 or smaller than negative 1 anywhere on the unit circle. So your range for both sine and cosine are negative 1 to 1. So some review topics, certainly, and that's where I know when we looked at some of this earlier in the chapter, kind of said these are you have to know your reciprocals, you need to know your quotients, and then I would say you also want to know your complements. So that covers the first half of 4.2.